The next speaker is Martin Felsen. Martin Felsen is the principal of Urban Lab and the Studio Associate Professor of Architecture at the Illinois Institute of Technology. Martin's rigorous practice ranges in scale from residential and public buildings to speculative urban design projects. His work has been widely published and exhibited, including in the 2012 Venice Architecture Biennale. Thank you, Martin.
Thank you very much. All right, thank you very much. Happy to be here. I am just going to turn on my timer. So I'm going to talk about an economic project called the WET Zone, the Water Enterprise Trade Zone. And this is a project that Deborah and I are collaborating on. It's a concept, just a concept. And we're also working with a studio at IIT. So it's defined by two problems, two of which Deborah have already kind of talked about, we've already talked a little bit about, but the first problem is that we divert about 1.5 billion gallons of water a day from Lake Michigan. And as Deborah suggested, we renew less than 1% of that, very small percentage. The second problem is that manufacturing jobs have really just disappeared from Chicago, but they've also, of course, disappeared from the United States in general. So we can see just between 2000 and 2010, the United States has lost 5.5 million jobs. If we zoom into Illinois, we see that about half the jobs were lost in that same time frame. And if we zoom further into Chicago, we see that almost 200,000 jobs were lost in that time frame. And about 200,000 people left Chicago in that time frame as well. And certainly there are connections there. There's a little bit of a history to this collaboration from both Deborah and me. My history of it is this precursor project that was started with Mayor Daley. And the mayor did believe that a future, let's say, sector of a sector that we could win, as Charles said, could be water-based, given that we have so much water. And so what we did with the mayor was that we looked at industries that use an enormous amount of water. So this is a map of water footprints. So for example, a pair of jeans takes about 3,000 gallons of water to make. And just up and down the line of everything that we manufacture and produce uses an intense amount of water. So what we thought we would do was to try to incentivize industries that have these giant footprints, and we thought we would try to incentivize them with free water. Essentially, if you move to Chicago into what we were calling a free water zone, that you would effectively be given this access to this resource. And these companies spend millions of dollars a year on water. So we looked at this site, which is on the south side near Calumet, near Indiana, post-industrial site, and you can see in the north huge housing worker stock, just lots of people that live in these houses that used to work in the steel industries and other type of heavy industrial industries. And we came up with this idea of almost like a free trade zone, this community of industries, of parks, and of research institutions that would be combined into this new kind of economy. So part of what the project was about controlling NIMBY type of resources or type of programs, such as recycling, parking, and we try to control that with the introduction of public space, so this park in the middle. This park also acts as a very significant and huge flood zone, because this entire development would theoretically be off of the stormwater grid completely, process its own stormwater, and send that back into the lake. So what would effectively happen is all of these industries built around this flood zone, which the flood zone would have perhaps an institution inside of it, would take water out of the lake, use it as much as they want, but then put that water back directly into the lake. So that project actually went nowhere after a certain amount of time. The mayor just got distracted with other things. We started working on vertical farms and other types of projects, and it just sort of withered away. Then a few years ago, after the project was kind of dormant, Jeannie Gang organized a small group of architects for the Venice Biennale, and we exhibited the project. Ours is in the kind of, Jeannie's is on the left, ours is in the sort of middle, Stanley Tigerman's is there. And the model that we built sort of re-speculated on the value of this infrastructural intervention that combined the relationship of architecture with landscape. And so this model that we produced really tried to figure out how to build architecture with landscape that produced this new kind of industrial setting for industry. The project then, or the exhibition then came back to Chicago. It was displayed here for a while. And about at that same time, Deborah Shore, as you saw, was writing a lot and significantly. And one of the essays that she wrote was in the Tribune, the Chicago Tribune. It was an op-ed that speculated on an idea for an enterprise zone powered with water near one of the water filtration plants. So we got together and strategized this next project that I'll briefly show. So the project went from a kind of port mentality to a park mentality. And this is the site that we're currently looking at. It's hard to see, but it's an incredibly toxic, polluted site filled with heavy metals, slag, other sorts of byproducts from the steelmaking industry. And then around it on three sides are these landfills. Just on the other side of the landfills are housing. So just to cite yourselves, here we are in the loop. The Calumet Harbor is just kind of due south. You can see the Metropolitan Water Reclamation District and then our site highlighted here. So the question that we had at the beginning is, what is the benefit of moving from this kind of park or free trade zone mentality, to this park? And it's right here, this very simple photograph of this almost raging river of water that leaves the filtration district every day, 150 million gallons a day. As Deborah suggested, that normally we ship down to the Gulf of Mexico. This is equivalent to these incredibly important lifeline type infrastructure projects in the United States, like the second LA aqueduct, which is pictured here, also a flow of 150 million gallons a day. So the value of this is significant. So what we did was we connected the Water Reclamation District project with the site with a simple pipe, essentially, of this millions of gallons a day. We think we can take about 20 million gallons of this recycled, what's called effluent, per day to power this new industry zone. So these are the industries. I won't really go into too much detail about them, but they all have these really heavy water uses. Skipping way ahead to where we are now with the kind of strategy plan, I guess would be the best way to call it, is we have a cluster of initial industries to the west. And to the east, along the river, we have a park for everybody that's down there that really doesn't have much access to amenities, these kind of, as Charles said, this kind of central district amenities. Looking at some of the renderings that we're coming up with, this will be a heavy industry area. We would have a number of these intermodal transfer stations on one side, but on the other side, we get this kind of more serene, typical, let's say almost conventional type of park for people, for everybody working there to bring their families on the weekends. Seasonality is really important. We wanted to make sure that the trains and all of the intermodal truck transfer station type of facilities on the west could really function through some of the pretty horrendous weather that we seem to be getting quite often. The number of jobs, these are a number of direct jobs, maybe 2,500 direct jobs, but for every direct job, there's 10 jobs that get formed whenever these kind of industrial processes are developed. The buildings were, again, based around what they're doing with this recycled water. And we developed a series of these diagrams. This one's an agrotech building, where we see on your left, water, this recycled effluent comes in, gets combined with natural products and processes, gets developed into products, manufactured products, and then by the time it's in the red zone, turns into an economy and dollars. And we try to calculate everything as it moves through. We also try to calculate the savings, let's say. So this is a paper plant diagram. On your left is a typical paper plant that uses trees, lots of trees. On the upper left there. On the right is how we propose to do it with using recycled paper. Just taking all the paper that we can get our hands on in the city, turning it again through water into these products. Another thing we're doing is looking at the industrial ecology of the entire site. In this case, how different buildings and industries operate together. So in this case, how the beverage building, which you can imagine how much water that uses, packages all of their goods for sale in paper instead of glass containers, paper containers, and how a lot of the waste from the vertical farm, for instance, gets reused as soil and fertilizes the landscape. We also looking at energy. We think we can take a lot of these landfills and turn them directly into energy, essentially harvest the landfills that are just filled with resources and turn them into electrical energy to power the entire entire wet zone. And lastly, the last slide is essentially we're trying to look at all of the waste that comes out of each industry and how that waste becomes resource for other industries, and how power essentially can power and water can transform all of the different waste products into all of the resources for the next industry. Okay, thank you very much.